Hi, welcome to the End-to-End AI Engineering Bootcamp's hands-on section. Throughout the upcoming weeks, we are going to build out a few projects. And this week, we are starting off with the simplest system possible, which is a very simple retrieval augmented generation pipeline. Now, the first project that we are going to build out is a e-commerce online shopping assistant, which will be controlled through a chat interface. For that, we will of course need some data, but before that, I want to introduce you to my development environment because this is what you will gonna see quite a lot. So you can see my cursor window now open in the screen. So I will be coding inside of the cursor IDE. You will also very often see two terminal windows that I'm using, one for running Docker Compose deployment and one for installing any additional new dependencies that are needed for the project. You'll also see my Chrome window from time to time because this is where we are going to test our application and sometimes look into documentation of our fast API endpoint, server endpoint. Now, you probably noticed that I already have some preparation work done in my cursor IDE. So you can see some code here already exists. And it is because I'm basing this project, which is called now 00 AI Engineering Bootcamp Cohort 3, on top of the prerequisites repository, which I have released a few days ago. Now, if you have missed that, you can still jump on the train and actually go ahead and see how I implemented all of this and prepared my own development environment, and you can feel free to follow that. If you want to do that, you can find this information in, if you would be inside of your student view right here of the platform, Maven platform. In the pre-course, you will see a section called Development Environment Setup, and you can click on it. And here you have a link to the GitHub repository where all of this code lives. And there are also 4 videos where I go along the implementation of what you will see in the repository. So the first video is about just setting up your development environment. So setting up your Python, getting your LLM API keys, and testing them inside of Cursor. The second video is about building a very simple Streamlit front-end application and then Dockerizing it and deploying that via Docker Compose. The third video is about deploying a fast API REST server for backend and moving the LLM calling logic to that server. And of course, deploying that server locally via Docker Compose as well. And the fourth video is about also deploying a new Streamlit front-end application, which would be communicating with the backend locally and deploying both of them with Docker Compose. So all of this is implemented in this prerequisites repository. Now, for this specific cohort, it's still not a prerequisite, but in the future, I'm planning to make this public and make it a prerequisite. Now, this is still not part of the first week, so it is a pre-course material. You can either clone this and just use it as is or follow the videos, which is recommended to fully understand what has been implemented here. But if you want to just follow this, you can click on the link and here you can clone the repo and you will have something similar to what I have here. So everything here, almost everything here is from that repository. Okay, so now back to the things that we are going to build. Today, or rather this week, we are building out our initial RAG application, as well as implementing some observability to this RAG pipeline and implementing some evals to evaluate accuracy and correctness of our RAG pipeline. Now, before we can even start working with RAG, we need some data. And as I mentioned previously, we will be, in this specific project, we will be working with, we will be building a e-commerce assistant, online e-commerce chatbot assistant. In order to do that, we will be borrowing data from openly available Amazon eShop dataset. And before we do that, let's create a new notebook. And we will be usually we will be implementing everything in notebooks before we actually move the code to production code. And today is no exception. We are gonna create some new notebooks. And since it's new week, week 1 that we are currently at, I will be creating a new folder right here. I will call it week 1, and all of the notebooks that will be relevant to week 1 will be held inside of this folder. So now I will create a new file, and I will call it 01 explore Amazon dataset.ipnb. So this is our first notebook, and I'll gonna copy some markdown text at the very top so that I can copy a link from there. And then we can see what kind of dataset we have online. So we can copy paste this URL or just click on it, and we will see this nice page popping up. And it is all of information that we need to know about how to download and work with this dataset. So what do we have here? We have mainly two tables that we are interested in, and one table contains user reviews for the items in the eShop, and another dataset contains information about the actual items that we can buy in the eShop. And those two datasets can be downloaded by clicking on one of these links. And for me, I specifically chose to work with electronics dataset, and not with all of it. I will subsample it, but I will be working with electronics. Why? Because I wanted to have something interesting to work with, and I also wanted to have a dataset which is, well, a little bit larger, because I wanted to do some pre-processing, filtering out. I didn't want to pick something that is too easy to work with. So electronics for me, you can choose any other category if you want. But in general, these two buttons would download these datasets. One dataset, a review, holding user reviews for these items, and meta holding actual data about the items in the eShop. Now, this is quite a large dataset. So we would have 18.3 million users giving reviews for these items. We have 1.6 million items and 43.9 actual reviews given for these items. So which means that the review dataset has 43.9 million entries in it, rows, and the meta file will have 1.6 million rows in it. Now, are these files big? The answer is yes. So when you download them, you will see they will download in a zipped form. And I believe it is around a few gigabytes in zipped form. But once you unzip them, the ratings dataset becomes, I think, 22 gigabytes. And the items dataset is around 6 gigabytes. So I will not download them live because it takes quite some time to download these kinds, files of this size. And I already have them downloaded. But before I look into them, let's see what kind of information we actually even have in these datasets. So for the reviews for the items, we have the rating given by the user. We have the title of the review, because review can also be titled. We have the text itself, so the body of the review. We have some images, if assigned. We have ASIN, which is ID of a product. We have the parent ASIN, which is parent ID of a product, user ID of a user who has given the review, timestamp, verified purchase, helpful vote. Now for items, metadata itself, we have the category, the title of the item, average rating given to this item, how many ratings have been given to this item, features, description, price, images of the item, videos if any, and then some additional data. Now, parent SN is the parent ID of a product, and this is what we are going to be using to connect these two data sets. And these will act as IDs of the item, and they will be connected via this parent SN to the reviews, or rather reviews will be connected to the items. Okay, so this was a very quick overview of the datasets themselves. Now we can actually go ahead and try and crunch this data. So let's just mark this down. And I will be using simple libraries for that. We don't need anything more than just oh, my mouse is stuttering. JSON and pandas. I think we do have. No, I think pandas we don't have yet. Actually, we do. So that's good. We don't need to install it separately. We do have pandas. It's taking quite some time. 10 seconds for the import. And what I have already pre-created is the data folder at the very root of the repository. So if you would look here, you'll have those electronics and meta electronics JSON-L files, and JSON-L is line delimited JSON file. Now we will not be able to inspect them because these files are extremely large, so 21 gigabyte and 5 gigabytes. So we'll not look into them like this, but we can go ahead and actually read the first line of one of the files and actually see into its contents. So I am pointing to the meta electronics file, reading the first line, and then I will be able to display it. We will not be working with electronics as of today. We'll be introducing electronics reviews a little bit later. For the first initial implementations of the RAG system, we will be only using meta electronics file, which holds information about the actual items and not the reviews. So that's why I'm reading that one, and let's see what we have. So first line looks like this. So as expected, we have the main category of the item. We have the title of the item, average rating, how many ratings this specific item has accrued, some features, if any, as a list, then description, which by itself is I think it's a list of strings. And then we have a price. It is potentially empty, so it can have none as well. Then we have images of this item and videos, the store in which this is available, categories, because it can have multiple, but it will also have the main category available. Details, which will be important to us because details also hold the date when this item actually became first available, and parent SN, the ID which we are interested in. Now, the first thing I want to do is to have only the items that first appeared in the store in year 2022 or 2023. So I don't want outdated items. I want only the newer items. This will help. First of all, this will help me to reduce the size of the dataset. But in general, working with newer generation of items is a little bit more interesting than digging through historical data. Even though this is historical, right? Because we only have information about in items up to year 2023, which is not that recent. Now I will copy paste some code from now and then because I want to save time on typing, and then I would rather go through the actual code itself. Yes, I forgot one. So this function, the first function, filter data, it basically takes in a dictionary, and it will take in these kinds of dictionaries. We will look for all of the dictionaries in the meta electronics JSON-L, and we will apply a filter and basically set the filter if the filter is set to true, it means that we are dropping this item, and that's hence why it is called filter data. So filter out the data. So initially, by default, it's set to false, and only if the date when the item was first available, and more specifically the year, meaning the last 4 digits from this string, is less than 2022, then we are setting the filter condition as true, and we are removing this from the dataset. Now we are not specifically deleting any data. We are, in this piece of code, we will be splitting our JSON-L file, Meta Electronics JSON-L, into 2 parts. One part will hold all of the items that have appeared in the stores between 2022 and 2023. And one will also be a what you would call trash data because it has no date. Yes, so we are not actually writing our data into any kind of file. And here we are simply looping through all of the items in the Meta Electronics JSON-L file. And remember, each of the item has this kind of structure, and we are applying this filter data. And if not filter, which means that we do not filter it out, we are simply writing this specific item to this new file, which is fbout, and we will be later dealing with those filtered out items. And we are catching an exception here because if date is not available, this one would fail. This function would fail because this is malformed in some way. And if we catch this exception, we are writing that data point to fbout no date, which is this file. We could just drop it, but just out of interest to check how many items are malformed, we are writing it out into this file. And we can just run this piece of code. It will print some logs, and it prints a log every 10,000 items, 10,000 lines. And it's quite fast. And remember, I think we have 2 million or 1.6, I think, million items in total. So it shouldn't take too much time to actually iterate through all of the available items and create our file of interest. Let's wait a bit. It's almost 1.6 million now, and yeah, so it processed all of the lines. And let's see what we have here. So no date. Actually, okay. So there are quite some items with no date. Let's see how many. Oh, that's quite a lot. 100,265 items that do not have date assigned to them. But okay, so we are disregarding these items, and Meta Electronics between 2022 and 2023. It's actually rendering. So we have a 1.2 million. Oh, no, actually only 115,888 items, which is still quite a lot, but definitely not the biggest chunk of the entire dataset. Because remember, we have 1.6 million items. So most of them are historical between 2022 and earlier. Okay, so now I also want to split this dataset into 2. One that does have the main category and one that doesn't have the main category. Because I want to analyze the dataset and see what kind of categories we have and which categories have more items. So I will mark down this section right here and call it split the items into 2 categories, has main category or does not have category. And again, I will implement a very simple logic, very similar logic to what we did before. I will apply a filter function, a filter category, and if the main category does not exist, then we are filtering out this row, and if the main category exists, we are not filtering out this specific row. And now we run very similar process to what we did before. Now we are simply, first of all, opening and reading a smaller file. Remember, only I think around 120,000 rows instead of 1.6 million. And we are creating two new files, one for all of the rows that do have the main category and one for the rows that do not have the main category. And we are running, again, this filter function on top of each row again. And we are writing those values into those two separate files, depending on the condition which was met. I'm not counting rows here anymore because this shouldn't take that long, as we are only working with 110,000 rows. Okay, so with category, this is the file we are interested in. This is the file with which we are gonna continue working from now on, and it has 104,000 rows. Now we could already load this file easily into pandas. And by the way, we are not using pandas. We were not using pandas here because loading that 1.6 million rows would be quite hard. It shouldn't be, but I tried and it does take quite a lot of time to load. Hence, we are first filtering the data out, and only then we will be working with pandas. And now we are already working with pandas. So first of all, I want to explore distribution of this data set by categories. And I will be looking into the data set of all of the items that do have categories. And I can read in now our data frame using pandas. So I will go ahead and do df equals to pd.read underscore JSON. And I'll point directly to the JSON file which I'm interested in. And it is located here. And its name is Meta Electronics 2022-2023 with category JSON-L. And lines equals to true, because this is a line delimited JSON file. Give me 1 second. Yes, so I forgot data here. Now it should work. Yeah, so it takes 4.7 seconds to load 104,000 rows. Now, the initial data set had 1.6 million, so that would have taken quite some time to load. Let's see how the df looks like. Sorry, let's just do df.head instead of this. And as expected, it has the main category, title, average rating, rating number, features, description, etc. So everything that we seen in this dictionary right here. Okay, so let's explore it a bit. What I wanted to see is the distribution of main category. So how many items in each category we have, and what kind of categories do we have in the first place. So I'm just gonna go ahead and count the amount of rows of each main category and plot them as a bar chart. Yes, so now I'm lacking a library. Matplotlib, it has not been installed yet, which I do need. And I can do that by... So by the way, I'm already at my working directory. So I'm already at the root of this repository. So if you want to run this, please navigate to the location where you have cloned the repository. And you can add a dependency into development environment with UV by running UV add dev, I think it was matplotlib, right? So it will install matplotlib, and also what we will see that if you look into this pyproject.toml, you will see that this new section appears, and this specific dependency is only installed in the development environment, which is great because we will not be using that in our production code. Okay, so now this should work, hopefully. If not, then we would need to restart the kernel, but it does work. So we have a bar plot of the counts of all of the items per specific category. So we have things like all electronics, computers, cell phones, and accessories, and this is the distribution. So naturally, like a overarching group called all electronics takes the lead, because probably anything that doesn't fit into other categories gets automatically placed into all electronics. But I was simply interested in the shape of the curve of the chart, because I wanted to make sure that once I am sampling this dataset, I at least to some extent maintain the distribution of the categories that I see here. So first of all, I want to reduce the size of this dataset, because I don't want to develop or at least start building a system with this many items. So I will try to narrow that down. The first way of how I want to narrow this down is pick only items which have quite a lot of ratings associated to them. And I just chose randomly a number, and the number that I chose was 100. So what I will do here, I will filter all of the items that have 100 or more ratings assigned to them. And we can very easily do that by simply applying a filter on pandas data frame. And if this regular DF had 104,000 rows, this DF data frame has only 17,000 rows. So it's already significantly reduced in size. And we can also see if the distribution of the items of the categories has changed significantly. And we can do that by just copy pasting this and changing the data frame name right here. So a lot less categories for sure. Computers are a little bit less lead taking than before, but in general it looks quite similar. So I'm satisfied with this. We are not trying to make any statistical measurements on the distribution, on the similarities of distributions, because I wouldn't assume that this kind of filter would necessarily keep the distribution, because potentially some categories are simply getting more ratings than others, because the items are of a certain quality, has certain quality to them. Okay, so now once I have this smaller dataset of the items that have 100 or more ratings, then I'm gonna do some exploration about the distribution of the ratings themselves. And what I am going to do here is plot a histogram on average rating for this dataset with 50 bins, and the range is between 0 and 5, because we cannot give a rating outside of this range. So this is how it looks like. We can see that most of the ratings are kind of situated between 4 and 5. And then we still have some really worse ratings, which is fine because this is what we want to have. We don't want to have only positive ratings overwhelming all of the negative ratings. And naturally, there's usually a lot more positive ratings assigned to items than negative, but negatives are, I would say, more important and interesting than positive ratings. Okay, so what else? Now I want to make this data set even smaller. So what I'm gonna do, I will be taking those, oh, sorry, my mouse is glitching for some reason, but I'm gonna go ahead and take those 17,000 items and sample them again and only retain 1,000. And that 1,000 will be my final data set. So I'm gonna sample 1,000 items, and we can very easily do that by running this sample method on top of the data frame that we had previously. And that data frame had all of the items that have 100 or more ratings assigned to them. So we are sampling 100 and setting a random seed that we can repeat the same sampling if we want to reproduce these results. And I want to make sure that the ratings distribution for this sample dataset remains at least a bit similar to what we had for a non-sampled dataset. Yeah, so these two definitely look very similar, and only the frequency is a lot lower. So this is what I wanted to see, which is nice. We can also check the price distribution of these items because we want to have quite good variety of it. So we can see that the prices are ranging from 0 to 500 mainly, which is surprising because I would have hoped potentially higher prices for some of the items. So the range is set to 500. Okay, so probably there are a lot more expensive items, but naturally most of the items are situated between 0 and 100 USDs. Okay, so what else? What else can we do? Okay, so now this only has 1,000 items. So let's also see how the main category is distributed now. Computers, cell phones, and accessories. So still, we can see the trend. I think the top categories are remaining the same, and they are also ordered in the same order as when it comes compared to the entire dataset. Okay, so we are gonna go ahead now and write these datasets to JSON files, and we are gonna reuse them in the future. So one dataset is for all of the items that have 100 or more reviews assigned to them, and one dataset is for all of the for the subsampled 1,000 items from that dataset. So I want to save them both so that I can refer to them in the future. So first is this one, which is larger, 17,000 items. Let's write them into the data folder. And the next one is this 1,000. And we are also writing it into its own corresponding file so that once we return to this data later on, we can always read the data set of interest, and we do not need to recalculate or resample the data set. Also, for the future, we want to prepare our reviews datasets. So let me explain what I mean by that. So reviews dataset has user reviews that have been left in the platform for specific items. Each of the item can have multiple reviews assigned to it, and we are also filtering out the items that have at least 100, which means that reviews are not unique per item, right? So you can have multiple reviews per item. So now we want to filter out all of the reviews that are relevant to these items from this dataset and from this dataset, and save them also in the data folder so that we can read them later and we do not need to do pre-processing as we need those files eventually. So first of all, let's just read these two datasets, even though we have them here, but let's just reload them into new data frames, just to make sure that the files that we have written here can be successfully read into Pandas. So we did successfully read them. Now we are going to filter out the electronics.jsonl file. And this is the file that has, I think, 50 or 60 million rows. And what we are going to do here, we'll be looking all of the parent ascents that are for all of the parent ascents, which is the product ID that are present in these files. So first we are working with this file, and if electronics.jsonl file, which holds the reviews, has the ID, the row has the ID of this specific dataset, then we are retaining this record, right? So we'll have all of the records for the reviews that have matching items inside of this dataset after running this specific piece of code. So it's running quite fast, right? So 100, we already have 1 million. And how many did we have in total? Let me remember. For electronics, we had 43 million. Okay, so this will be running for quite some time. Let's see. So so now it's at 6 million only. So that's probably around 2 minutes until it finishes. In the meantime, we can actually look into what is happening here. So first of all, we are reading this file, and actually we'll be writing to this file. So we are reading the electronics file, and we have this data frame where we have all of the items that have more than 100 ratings. And then we are extracting all of the parent ascents as a list and transforming it into a set. And then we are basically checking if the row of this data set and that and a ID from that specific row is in this list. And if it is in this list, then we are going to write that specific record with the user review to this file right here. And we are looping through those 48 million, I think, rows right now, and figuring out what we need from this reviews file. Now for this data set, we know that it is a subset of this data set, meaning that if the ID is present in this data set, it will also be present in this data set. So this data set right here, which has reviews filtered out for all of the items that are in this data set, will hold all of the user reviews for the items in this data set as well. Just, because this is just a subset of this specific data set. So now for the next filtering out, we will not need to read the entire file of electronics.jsonl. This file will be enough. So we will be filtering out this file, and it will probably be very fast. Let's see how it looks like, and let's try running it. Right, so now we are opening this one and running filtering on top of it. That's still quite a lot, 1.7 million. Okay, so we filtered out through 1.7 million rows. and we have our reviews dataset. So now we can forget about reviews. What I'm interested in is the actual metadata files that we have here. So the dataset with 1000 items, more specifically. Okay, so I have datasets ready. I did some exploration. We could do a little bit more, but I want to keep this simple, and I will be using this dataset in the next video to create a dataset for our RAG application. So thank you for being with me in this one, and hope to see you in the next one. Cheers.